Humanity is a resourceful bunch. From stone tools to 3D printer, manufacturing seems to be our never-ending goal. The Paleolithic Age brought us Stone Age technologies to produce the means of civilization shift from nomadic to settlement societies. With stone tools, agriculture became more of a reality as axes were used to clear farmland. Stone Age humans were simultaneously making music, traveling the ocean, and waging war. They never talk about that on the Flintstones, do they? The earliest steam-powered device, the Eolipile, was developed by the ancient Greeks, but steam wasn't really harnessed to its potential until the Industrial Revolution. The Watt steam engine was the first of its kind and set the standard for engines that created the first iron bridge in the world. I bet all the people who invested in the water wheel were steamed by these developments. The Second Industrial Revolution saw the ramping up of the steam engine applications into steamboats and railway transportation. In America, interchangeable parts made manufacturing in large scale more viable. Oddly enough, it begins with guns, which harkens back to our Stone Age ancestors. Also, agriculture machinery and mass-produced bicycles came into being. The latest industrial leap is the 3D printer. Basically, the 3D printer is an industrial robot which can make anything it's programmed to, including, you guessed it, firearms and other warlike materials. We've advanced so far, but with the medical and manufacturing leaps and bounds with 3D printing, I suppose a few plastic guns are a small price to pay.
This is the ultimate design tool because it blurs the boundaries between styling, 3D CAD, clay modelling and engineering.
This project was born out of necessity. We had to create this to actually streamline the design process.
So you're drawing effectively at full scale, continuously checking the stance and proportion to make sure that the effect of your changes will get through to that end product. Traditionally, sketching cars, you have to transport yourself around this thing that you're drawing on a 2D surface. What you don't get from a sketch is the dramatic stance and proportion of a car that you get in real life, and actually you do get that in virtual reality.
Being a designer who can code and working with an automotive designer really helped us focus and concentrate on what we truly needed to create.
What we needed was something that was specifically a design tool for 3D drawing and modelling. Because we're sketching at full scale, it means that we can evaluate the stance and proportion of a car live. Design is an iterative process. We needed a functionality where we could place variations of the work we're doing and assess them next to each other, and then you can move from sketch lines into a spline tool. We can pick up more than one point, we can move them in different directions while placing and assessing the shape of a curve, which is essentially creating data that I can export to a modeler and use to build 3D models from. Because it's a virtual environment and it can be networked, that means that anyone, anywhere can join us in the virtual world and work collaboratively.
One of the most exciting features we developed was the implementation of augmented reality. Traditionally, VR is a closed-off experience for one person with a headset, and what we've allowed with a mobile app is multiple people to engage with the drawing at once in a collaboration mode.
Seymour Powell have been a London-based design agency for over 30 years. What better place than the London Motor Show to showcase this to the world?
5 is the Ford Immersive Vehicle Environment. It's a new and different approach to doing virtual reality. It presents you a stereo view of a virtual world, and you have a life-size vehicle, in this case a Mustang, in front of you that you can interact with just like you can interact with the real Mustang. You can look at things before you build them. We want to understand the design and the proportions of the inside to the outside, and we can move things around and quickly study thousands of options without ever having to produce a physical thing. I definitely believe that the work that we're doing is affecting the development of vehicles around the world. Automotive is an industry that's constantly evolving and changing. In Southeast Michigan, there is a growing contingent of people that are working in gaming and in visualization and tracking technologies that are much more applicable to the automotive industry than ever before. If you love technology and you really appreciate a high quality of life, you really ought to think about Michigan. Working at Ford and being in this virtual reality environment, and it's really about how to cheat the natural world. And then I come here and it is the natural world. So Michigan to me means both of those things. I can innovate and then I can come home and just be in that natural world. I have it all. What we do in the 5 Lab is immerse you inside a virtual Ford, and the whole goal is to represent the customer and bring the voice of the customer into our product design process. Now you can see what Dan sees, but Jim is also immersed, and so each one can assess their position in the vehicle and talk to each other about different ergonomic or visual aspects of the car. And we also have virtual hands, so when you wear this, it becomes your left hand. He can look at the steering wheel, put his hands on the wheel, and assess whether he has good visibility of the gauges based on where his hands would be. And then he can look over at the shifter, put his hand on the shifter, and make sure that that's an acceptable reach. He can also look around the vehicle and look all the way into the back. So even though in the lab there's not a virtual vehicle here and not a complete representation in the physical world, he has the full representation in the virtual world of that vehicle. We were just at the virtual space where Dan was immersed inside the virtual focus, and now we're transitioning over to the programmable vehicle model. So Dan, yep, why don't you hop in and I'll shut your door for you. And this is the programmable vehicle model. And so what this does is it morphs into any vehicle we would like to consider producing. And then we can set it up so that the virtual world and the physical world are married together. He has his own arms and hands on a physical wheel, and he can also see the virtual wheel at the same time. And so the beauty of that is that we're really bringing the physicality of operating a vehicle into the virtual world. So Dan feels like he's in an F-150 right now. All the physical components are good and it feels right. But 5 minutes later, we can configure it so he is sitting in a Mustang. So this programmable vehicle changes, and he would sit low and he would sit sporty feeling, and then the virtual data that he would see would now be a Mustang. So it's that easy to switch between one vehicle and another vehicle. So we can literally schedule people on the hour to come in here and look at different vehicles, and we're incredibly responsive to design and engineering. So now we're here in the cave, and John is here with me, and he is going to put on a pair of tracked glasses. And so the same principle applies where we track where John is looking in the virtual environment, but now the vehicle will be projected out in the room to John, and so he will feel like he is immersed inside of a virtual Ford. So why don't you have a seat up in the vehicle seat. And so now you see John is inside the virtual vehicle, and he has an understanding of where the components of the vehicle are with respect to his environment. And now he has this really great wide panorama, so he can look all around. He can look behind, and he can get an understanding of the wide field of view that you need as a driver. So we can use this technology to understand vision requirements and make sure that we're adequately and perfectly covering what we need to for the customer's vision. We're still in the virtual space, but now there's no vehicle here. There's no vehicle seats. And so now we do have the whole car in the environment. So I can put on the head-mounted display and get the stereo view of my virtual world, and now I see before me a virtual car. And so now I can evaluate this car for quality. So I can make sure that the gaps and margins are good and that we have a nice consistent interface. So if I look here at the margin of where the fender meets the front fascia, that's a nice tight margin. The wheel looks really good. If I look down the vehicle and I look at the character line, that's a really nice character line with really good flow. And so now I can look and inspect the vehicle. And so now I'm at the front end of the vehicle and I can walk around to the rear. So now I'm looking at the rear of the vehicle and looking at that nice tight margin there and the exhaust and making sure that everything is exactly as it should be in the virtual vehicle.
We live in the age of a digital revolution, and we listen every day a lot of words like virtual engineering, digital manufacturing, industrial Internet of Things. And our people are very involved in this technology development. So the main areas of our simulation technologies are crashworthiness, safety, soil and crop modeling, ergonomics, fuel consumption, and finally virtual reality.
We use virtual reality for modeling the tractor or the industrial machine that for the moment does not exist. With the help of virtual reality, we are able to enter in a machine that is not yet existing.
With this technology, we try to reduce the number of physical prototypes that we have to build by building as many virtual prototypes as possible. We try to optimize our design in the virtual stage by doing as much testing as we can before we go to that physical prototype. Therefore, we can really optimize it and try out as many design options as possible.
Hi, Gennaro. Hi. So let's walk through this transmission a little bit. So you can see we have the final drive here on the left. You can see the hydraulic motor up here. And we can make sure that we have a tool clearance to where we need to get to by grabbing the tool.
In the virtual reality room, we use collaboration tools in order to share a solution between several teams. So we use the digital representation of the model of the vehicle, which is called a digital mock-up. In this way, the people can share the same solution and can work together without being physically in the same location.
And that's everything I wanted to show you. Thank you, Gennaro.
Thank you, Andrew.
So a little while ago, I showed you a demonstration using our tracking system to walk around and pull apart a virtual components. This allows the user to really get an understanding of the space claim of all these components, of any clearance or interference issues that may exist there, and so you can pull it apart and get an understanding of kind of the overall size and overall structure of the machine. It's much different seeing it that way than seeing it 2D on a computer screen.
You have seen that to run all complex simulation, we need high performance computing. Today we have a network of high performance computing of about 2,000 cores. We have several HPC servers all around the world in the different regions.
For me, it's very exciting is stay in contact with humans, with people, understand their needs, what is comfortable for them, and so help them stay well inside the product. And for this reason, I interview people, I make questionnaires, I go with them in field and really drive with them and taste the product like they do. And so, making this experience, I'm able to interpolate the information and reproduce in my virtual world.
The new digital technologies will transform the way we think, we design, and we produce our product. This technology will require new skills and new jobs, but our people are already prepared for this.
InScale, Europe's leading presentation company, has been innovating traditional PowerPoint designs for over 15 years. With a client base of Fortune 500 companies, we are pushing the boundaries of sales, marketing, corporate, and HR PowerPoint presentations. Now, we are embracing the future with InScale Interactive. Our team of experts are on the bleeding edge of technology, developing virtual reality, augmented reality, and mixed reality presentation solutions to engage your audiences in new and meaningful ways. Compared to traditional media, this new technology offers a new way to limit distraction and increase engagement and retention. It builds a much stronger emotional connection to the content, and we're just starting to scratch the surface of what this means for the future potential of corporate presentations. It's a very exciting time. No other company has a capability to immerse you in corporate, HR, sales, and marketing presentations. Immersive, interactive, and engaging. We are InScale Interactive.